Welcome all of you to this video of Maths Made Easy. I had promised in the last video, that is where I did HCF, where I did prime factorization, I had told that my very next video will be HCF problem sums. Okay, so here is my video with HCF and then HCF problem sums. Now these problem sums sometimes seems to be very difficult. Generally they are not difficult had they only taught you HCF. But the thing is, when they teach LCM and HCF together, now you don't know that sum is applicable for LCM or for HCF. Okay, so after this my next video is going to be LCM videos with problem sums, and then you will understand how both are different. So keep following my channel. If you have not subscribed, please subscribe. You will get instant notification. Okay, also send me a comment there if you want any particular difficulty in any particular topic. I'll try and help you out. Okay, let's start then. Now let's take HCF, which means highest common factor. Okay, highest common factor. Now sometimes also earlier it was called GCF, greatest common factor. It's the same thing. If some book is telling GCF, it is nothing but HCF. Now what is highest common factor? Now if they are talking about the word common, there has to be two, at least two numbers, then only common can come, right? So if I have, let's say if I have 5 and 10, now 5 has factors 5 and 1, 10 has factors 5, 10 and 1 and also 2. Now which is the highest among these? Okay, so the highest, and it has to be the highest among all the commons, because one is also highest, one is also common. Okay, but it's not the highest. So these two are the common factors, but between them the highest one is 5. Therefore the HCF of 5 and 10 is 5. Now the same thing can be done for more than 2 numbers. 3, 4 numbers can also be asked. Okay, so let's take 2 numbers, 84 and 90. How do we find the HCF? Let's see. 2, now you know prime factorization. This is 42 and 2, this is 21 and 3, this is 7, this is 45, this is 3 and 15 and 3 and 5. I have finished prime factorization. Now for 84, okay, 84 the factors are 2 into 2 into 3 into 7, okay, 21 into 4. For 90 the factors are 2 into 3 into 3 into 5. Okay, so here what are the common factors? The common factors are 2, the common factors are 3 also. Okay, and so these are prime factors, remember. Okay, so HCF, when we look for highest common factor, it need not be a prime number, it only has to be the highest factor. So we have split it into factors, into prime factors. Now nothing else is common. So what is the HCF? So now what we will do, HCF of 84 and 90 is equal to 2 into 3. Don't take it 2 times. Okay, 2 into 3, which is equal to 6. Okay, so 2 into 3, which is equal to 6 is the HCF. So what we do, we pick out the numbers which are getting repeated in both, and then we multiply them and give the answer. Few more examples we'll do. 72 and 120 and 192. There are 3 numbers. Okay, so we'll do prime factorization. 2, 36, 2, 18 and a 2 and a 9 and a 3 and a 3, 2, 60 and a 2 and a 30 and a 2 and a 15 and a 3 and a 5, 2 9s are 18, 6, 2, 48 and a 2, 24 and a 2, 12 and a 2, 6, 2 and a 3. Okay, so full prime factorization has been done for these. Now I will write it like this: 72, 2 into 2 into 3 2s and 2 3s. Okay, here it is 120, which is 3 2s, and then I have 1 3 and 1 5. Then I have a 192, which is 2 into 2 into 2 into 2 into 2. Okay, 5 of them and a 2 and a 3. So this, let's take the prime numbers. See, 1 2 3 sets. Okay, there is a set of 3 also, just see here. Yes, there's a set of 3. Okay, but then nothing for this 5 and nothing for these 2s or this 3. So my HCF is equal to 2, 1 from this set, 2, 2 and 3. Take 1 from each of the sets. Okay, so that is a 8 into 3, which is a 24. So 24 is the HCF, highest common factor for these 3 numbers. What it means is these numbers will be divisible by many numbers. Okay, a whole lot of numbers can divide this. But the thing is 24 is the highest number, the biggest number which divides all of these 3. Okay, so one thing I want to tell you all here, this is a very important thing to understand. Highest common factor, HCF, is always going to be either less than the smallest number. It has to be either, in this case, less than 72, or max it can be equal to 72. Okay, it cannot be between 72 and 120. No. If you are getting an answer which is 90, you are wrong, because the number 90 can never be a factor of 72. Can 90 ever divide 72? No. That is why you can never have a number 90. Okay, so, or you can't have 125, because 125 will not divide these two, so can't be a factor of this. So it has to be smaller than the smallest of all the numbers, or at max can be equal to the smallest number, not bigger than that. Okay, 101, 573, and then we have 1077. So here this does not go by 2, 3, no, it doesn't go by anything. Okay, so 4, 5, 6, 9, no, 11, no. Okay, so 101. So 101 is a prime number, we can't get any factors. Okay, 573, this is 12, 13, 14, 15. This is going to go by 3, 1. This is 19, yeah, and 1. So this is a prime number. I can't find any factors of this. You don't necessarily have to know every prime number. Okay, you can check. Okay, I checked for 9, I checked for 3, I checked for 7. It's not going with any of these numbers. So this number is prime. Then here, this is 14, 15, goes by 3. Yeah, this is 5 and 9. Okay, 8 and 9. 8 and 9 make a 17. So this is not going by 3. Not going by 7 either. Okay, so I am checking with many numbers, it doesn't seem to go by anything. Okay, so this is again a prime number. So we don't have any factors in common. 3 is a common factor between these two, but then this one does not have 3 as a common factor. So when this happens, the only common factor is 1. So you can get a sum like this. Right now what we did was a prime factorization. Now we will do division method. This is absolutely new for you all. Division method of finding HCF. Before this we did prime factorization method. Okay, so division method works better for 3 numbers. So works better for bigger numbers. So the numbers are 255 and 357. Now whichever is smaller will divide the bigger one with that, 255. Now see, 1, 255, and this is 2. This is 102, right? Now starts the important thing. Whichever was the divisor, that I will write here, means the remainder will divide the previous divisor, 255. This will go on. This is 2. This is 204, which is equal to 1, 5. Okay, again this is going to divide this, so you should not confuse. With practice you will learn. 202. Now see, the remainder has come to a 0. Okay, that means this number is the HCF, highest common factor is 51 for these two numbers. Why? Because it was the last divisor. So this is the method of division method of prime factorization. Let me take up now 3 numbers, 2, 2, There are three numbers here. Okay, 2261, 3059 and 3325. Take any two numbers, this one you divide by this. Okay, 3059 and 2261. So this is going to go once clearly, 8, this is 9, 7, and now this number is going to come here. This is 2, this is 1596, 0, this is 7, this is 6, 6, and this 798. Okay, again 1, 670. Okay, 8, 2, and 1. Okay, now 128 will divide. So once we get 798, here this is going to come 2261. It is going to go twice, 1596, right? This is 5, this is 6, 6, and here it is going to go 798. This is once 665, 3, and then 3 and 1. If I write 665 here, I can clearly see it is 5 times. Okay, so 665, this is okay. So 133 is the HCF of this and this number, but still this is there. Now I'll divide it once and check, okay, whether it goes or not. Okay, so this is 133. So this is going to be 665. So it is not leaving any remainder. So this is divisible by this, hence 25. It is giving a proper no remainder. Therefore, 133 is the HCF of these three numbers. So we did one by prime factorization, we did one by division method. Now this question says find the largest number which divides 245 and this, leaving 5 in each case. We can see largest, then we can say divides. So we know it is highest and we know it is a factor. Okay, and both of them so common. So we are kind of reaching to highest common factor. But I want to tell you all here only, the word largest always does not indicate, blindly by seeing largest, you shouldn't go for highest common factor. Okay, now what we'll do is, now divides this, but it does not divide completely, properly. It leaves 5 in each case. Then 245, from that if I subtract 5, I get a 240. And 1029, from that if I subtract 5, then I get 1024. So these two numbers will be divisible without any remainder, because if I cut out the remainder, you see, if I have a 39 and I am dividing with a 2, 218 and 219 and 38 and 1. So in the beginning only, remainder is 1. So in the beginning only, if I take out this, this one, 39 minus 1, which is 38. Therefore, when I divide 38 by a 2, I don't get a remainder. So that is completely divisible. That is exactly what I am doing here. So now leaving 5 in each case. Now you find the HCF of these two. It is completely up to you how you find it, but this is always faster. 1024, the method of prime factor division method is always faster. Okay, 4 gives a 960, 4, 6, and write this 240 here. Okay, here 6. So 64 into 3, because 64 into 4 is a straight 240, but here 60 into 4 is a 240, but here I have a 64. So 192. This is 8, 4. Yeah, now 64. Okay, 148. This is 16. Yes. Now I have 16. I have 16 as the remainder. Again 16. Then what will I put here? 48. The previous divisor, and I get a 3. 48, 16. 16 is the HCF of these two numbers. So the largest number which divides this and this with 5 as a remainder is 16. Okay. Find the largest number which will divide this, this and this, leaving remainders 7, 11, 15 respectively. Okay, so which will divide this and this respectively means 7 is for this, 11 is for this, 15 is for this. So let me do the subtraction just like the previous one. 391, 436 minus 11, because if I take out the remainder, only then it will be able to divide completely without any remainder. So I am subtracting the remainder in the beginning only. Okay, so 430. 425 and 542 minus 15, which is 527. So these are my numbers which are completely divisible by that largest number. So now I'll do HCF. So now this is 34 and 391 here, 134 and 51, again 134 and 770. Yeah. Now put this 34 here. Now you can clearly see it is going to not leave any remainder. So this is, so 17 is the number. That 17 number I will try out again with 542. 17, 3 is 51, 30. Now this 17 I am going to try out with 527. 527, this is 17, 3 is 51 and 17. So clearly no remainder. So this is 17 is the so HCF is equal to 17. 17 is the HCF of these three numbers when they leave remainders like this. Okay. So the length, breadth and height of a room are given. See, it's given in meter and centimeter. You have to be very careful in this. Determine the largest tape. You know, this is what? Tape means what? Measuring tape. You must be having one in home, no? That is, or sometimes people who do, they construct buildings, they will also have one. They will, you know, masons and all, they will pull it and then you leave it, it goes back, that kind of a tape. Or the meter tape. Okay, that is, it comes folded. Okay, that folded one. So the largest tape that can measure 3 dimensions correctly. The 3 dimensions are the length, breadth and the height. You want the largest tape. Means if this is the length and this is the breadth, you want the largest tape which is correctly, this word correctly, of course you can measure any dimension with any tape. But the thing is, you can, maybe it goes 2 times full and then you have to take half of the tape. That is not correctly. You have to take on full whole number times. Okay, full 2 times, 4 times, no 4.5 times, no 5.5 times, no 5 3/4 times. That is what I mean by the correctly. Means you can take the tape little smaller, that is fine. But then it should end as this length is ending, your tape should also end whole number of times. That's the meaning. Okay, so what does it mean? If my length is, I'm just giving a small example, 15, then the tape can be, the biggest tape that can measure it probably is, if I don't get a 15 centimeter of course, then maybe 5, okay, 5 will cut it into 3 equal parts. So don't you think the length of the tape that I'm taking is actually dividing the dimensions. It is actually dividing the dimensions. When it is dividing the dimensions, it is a factor. Okay, because it is dividing completely. There are no halves and 3/4. Okay, so it is dividing completely. Now the same number, the same divisor or the same factor has to work for the length, the breadth and the height. And there can be many numbers which is dividing the length. There can be many numbers which is dividing this. But you have to look for the biggest one which can divide this, this and this. So what are we looking for? We are looking for the highest common factor. This word largest is for the highest. Okay, measuring here is dividing. Okay, so highest common factor. As long as a number divides another, it is a factor. Okay, so here we are going to find the HCF of these 3 numbers. But these 3 numbers, don't ever try to find 8 meter 25 centimeter is this many centimeters. 675 centimeter. Okay, 450 centimeter. These three, yes, these three are the dimensions. Okay, now what will measure it correctly? So we have to find the LCM. So what we have to do now is, you can go for division method. So 8, 25 and 675. Okay. Now here 1, 6, 75. This is 0 and 5 and 1. 6, 75. Yeah. This is clearly 4 will give me a 600. Then 75. This is 150, which is 2. So 150. Okay. So this is 150, 75. So this is the number which is the HCF of these two numbers. Then 450 and 75. So this 75, 33. Okay, so this divides it completely. So now this is my HCF of the 3 is a 75. So my tape has to be 75 centimeter long. Okay, not full 1 meter. So this is a question, rectangular courtyard. This is the length, this is the breadth, okay, this much broad, and it is to be paved with square stones of the same size. Stones have to be of the same size. Find the least possible number of such stones, and stones have to be square also. Okay, so all four sides have to be equal, and then least number. Now let me ask you something. I give you one sheet of paper, and I tell you, fill it up with squares, which is the least number of squares. Okay, fill it up with the least number of squares. So maybe you will just do this. Yeah. So bigger the square, these squares, you fill it up with 4 squares. Bigger the square, smaller the number. Okay. Now if you do this, then you get 16, right? If you do this, you get 16. So, but then these are smaller squares. So you have to have biggest square, the biggest square possible that can divide this, that can fit into this paper. Okay, so the least number of squares means the smallest number of square means the biggest size of square. Okay, so you have a room and you tell the mason put tiles which are you have to put tiles here with the minimum number of tiles, finish off the job. Okay, so what he does, he puts the biggest size tile available in the market and another thing. Okay, what is that another thing? That tile should here, it should fit here also. I mean, it should divide the length and the breadth correctly. Means you don't have to break any tile, no half tile. So because paved with square stones, they are not going to take any half broken squares, okay, of the same size. So they don't want any halves over there. So that will be a different size. So they want square stones of the same size and the least number. Now what to do? Now if supposing I'm just changing the numbers then it will be easy to understand. Supposing this side is a 15 and this side is a 20. Okay, so I have to look for the largest square. Now squares have equal size. So I have to look for that number which is the biggest number which will divide this and which will divide this. In that case, it's going to be 1, 2, 3. All 5 centimeter ones. 5, 5, 1. And here it will be 4, right? 1, 2, 3, 4, because square will be made like this. So this 5 and this 5 will make a square. So whatever I take here, same I have to take here because it's a square. Okay, so whatever I take this way, again same has to be taken this way also because it's a square. So what I have to do is 15 and 20 is HCF I have to find. Highest because I want the biggest square, common, because I want the same 5 here to 5 here, you can't take 6 here, then it will become a rectangle. So 15 and 20 is HCF, highest common factor. So exactly that I am going to do now. So here 2016 is 2016 and 1560. 1560. These are my two dimensions. So now I'll do the division and let me see how many squares I get. Okay, now here this sum is little difficult. 2016 and 1560. This is 6, this is 5, this is 6, 4. Okay, this is 1560, which is 3, 1, 3, 3, 1368. Okay, that's a 2 and 7, 9 and 1, 192. This is 456 again here. This comes 2. Okay, because 3 itself is 57. 19 into 3 is 57, so I have to take 2. This is 4 and 384. Now I get a 72. 72 will divide 192. How? So 7 into 2. 7 into 3 won't work, 2 only has to work. So 144, that is how much? That is 48. Yeah. 48 is now going to divide. 48 will divide the previous one, which is 72, which is 1. 48. This is 4 and 2 and 48. Now see, this itself shows the sum is going correct. So 48. Okay, so my HCF of these two numbers comes to a 24 centimeter. But that is not the answer. This is the side of the square. They didn't ask for the side. They said how many such tiles do we need. So the length is 2016 and 1560. So here if I place tiles, okay, how many tiles? The number of tiles is here whatever number fits, here whatever number fits. If I multiply, I get my number of tiles. Okay, remember the chessboard. Here 8 boxes, here 8 boxes. Together 64, what? 64 boxes you have. Same thing we are doing now. So 1560 divided by 24. Okay, you can do this division and that comes to 65. Then 2016. 2016 divided by 24 again, and that comes to 84. Number of tiles is equal to 65 into 84. Okay, that comes to 5460. Big number, but then the length was also quite big. Okay, this is this many centimeters. Okay, so this is also 20 meters and 15 meters is not a small number. So 1560 number of tiles are required. Okay. So those were the difficult questions that I could find out for you all and solve it here for HCF. My next video is going to be an LCM video with problem sums. Okay. So in the meantime, you can keep practicing this. Any doubt, please ask me in the comment section. Thanks all of you. Keep liking. Keep commenting, keep subscribing. Thanks. Bye then.